Hey everybody, it's me, Denise De Los Santos. Today we're going to start off with our interactive lab number 2, which is the do-it-yourself lava lamp with the Alka-Seltzer. I'm really excited for this lab because I've never done it before, and I'm really excited just to see what the outcome is. For today's material, we're going to go ahead and have a large water bottle. Today I'm going to be using this one. It does have a blue tint to it. So try not to let that sway you so much. And it is filled up, I would say about a little bit of a third of the way. I'm not going to be using the whole thing. This is just the only water bottle that I had around that was already used. I definitely don't like to waste water. And we also have some food coloring here, red, some Alka-Seltzer tablets, and we also have vegetable oil. So in today's lab, we're going to go ahead and utilize these supplies and see if we can go ahead and make a do-it-yourself lava lamp. And like I said, this is the first time I'm going to be doing it, so I'll be talking it through with you, along with discussing what is actually happening, what processes are currently taking place as we move along. So the first thing we're going to go ahead and do is add some vegetable oil. We did get the chance to watch a video online, and it did give us the example of how to prepare this. So we're going to go and add you can see the water bottle right here. Water bottle filled up with water. We're going to go ahead and fill it up with some oil. And we're definitely going to put a generous amount of oil. And this is vegetable oil. So one thing I learned growing up is water and oil do not mix. So as you can see here, that is true. You can see a layer of water and then a distinct layer of vegetable oil laying up here on the top. So I'm just going to add a little bit more vegetable oil. I can technically add this whole thing if I wanted to, just to get rid of it. Okay, there we go. Okay, there's all of it. The remainder I had. And there it is. So 2 distinct layers. So next, it's set to add about 10 drops of your food coloring, and this color is red. And then we're going to go ahead and see what happens when we add the food coloring to the bottle. Okay, so I added 10 drops, but I'm definitely going to do a little bit more than 10 drops. Let's see. Maybe it more meant like squirts. Okay, so this looks good. 10 drops. So as you can see now, with the 10 drops, there's definitely a separation of the oil, the food coloring, and the water. I don't know if you can see it. Let me see if I can get these lights to, let's see if that looks a little bit better or brighter. Okay, there it is. You can see it, the layers, the food coloring. Yes, there it is. Perfect. So all of it pretty much looks separated. And now we're going to go ahead and add the Alka-Seltzer. So it didn't say to seal the cap after, and for maximum results you can go ahead and use 2 tablets. So today I'm going to be using the 2 tablets of the Alka-Seltzer. So I'm just breaking it up right here, my fingers, and adding it in. I can see the tablets are dissolving in there, and carbonation is starting to take place. And how cool is that? It's pushing everything forward, and it actually does look like a lava lamp. How cool is that? Everything is moving inside. And you can even hear it fizzling. That is awesome. And I believe it said this could last up for a pretty long time, for a couple hours actually. So it worked. You could hear it too. That's awesome. So I did add a little bit more drops. I would say I added about 15 drops of the food coloring. So this is really cool experiment. But let's go ahead and discuss what's happening. So you can definitely see that the carbonation of the Alka-Seltzer started to push around the chunks of the food coloring, and the oil at the same time. So that's what kind of caused the lava lamp actual experience of everything moving around. So let's go ahead and discuss about what's taking place right here. So first off and foremost, we definitely see that density is one of the processes that is currently taking place, with the addition of just the water and then the vegetable oil. So as we can see, that is that density is the measurement of how a substance can impact one another and how it could fit within a certain amount of space. And as we know previously in class, we learned that density equals mass over volume. So if you measure an equal amount of water to oil, you'll find that water is heavier than the same amount of oil. This is because water molecules are packed more tightly together, and a cup of water actually has more mass than a cup of oil. So because the water is more dense than oil, it will sink to the bottom when the two are put in the same container. So density is affected by temperature. Other factors include, density is affected by temperature. So the hotter a liquid is, the less dense it will be. So that's one of the processes that are currently taking place. That was just with the water and the vegetable oil itself. So the second process that's taking place is polarity. So polarity prevents the oil and water from mixing together. Water molecules are polar because they have a lopsided electrical charge that attracts other atoms. So the end of the molecule with the two hydrogen atoms is positively charged, and the other end with oxygen is negatively charged, just like a magnet is. Where both poles are attracted to the south poles, and in our previous lab we actually talked about how opposites attract, and then how two like substances or elements will go ahead and repel each other, so that has to do with repulsion as well. And the positive end of the water molecule in this case will connect with the negative end of the other molecules. The oil in this case, however, is nonpolar, so they don't have a positive or a negative charge, so they are not attracted to the water molecules. And this is exactly why we learned when we were very young that oil and water do not mix. The denser liquid sinks, as we discussed previously, but usually with the lava lamp, you plug it into the wall, and that usually generates heat, and that's what causes movement in the regular lava lamp, so we actually plug into the wall. But in this case, we went ahead and utilized the Alka-Seltzer to go ahead and cause the actual movement to take place. The food coloring in this case is a polar molecule because it dissolves in water. Vegetable oil is not affected by the food coloring because they're polar opposites. And that's why we had the results that we actually had when we added the Alka-Seltzer as well with the food coloring. Instead of using a light in our homemade lava lamp, we used Alka-Seltzer, as I mentioned earlier, to go ahead and power that movement. The Alka-Seltzer reacts with the water to produce carbon dioxide gas bubbles, and that was taking place once we added the Alka-Seltzer inside to the bottle. Uh, these gas bubbles that are created, these stick to the water droplets, and the gas water combo is less dense than oil, so they rise to the top of the bottle itself. And at the top, the gas bubbles pop and escape the bubble escape the bottle, allowing the dense water to sink back to the bottom again. So that's why we have the outcome that we currently have right now. So as you can see, we have the vegetable oil on top, and then we have that denser water with the food coloring at the bottom. And that's pretty much what took place in today's do-it-yourself lava lamp lab. If you guys have any questions or if you're not able to access this video, please let me know. Thank you guys for your time.